Hello and welcome to a Nostalgic Ramble with me. We are looking at IEB's paper 1 from May 2024. Today we're looking at question 9b. If 5x plus 1, 2x plus 6, and 4x minus 3 are the first three terms in a converging geometric sequence, then determine the values of x. Okay, so this is definitely like a question where there's immediately an approach that comes to mind, but I would also just like to maybe spend a little bit of time talking about possible approaches to questions like these when you're not immediately sure, when you don't immediately have an approach that comes to mind. So what I like to do with questions involving, finding the value of an unknown is I just guess. I just guess some number, right? So I say maybe x is equal to 1. And the point of the guess is not for me to, by luck, stumble on a number that happens to work, but it's more about me inspecting how I then verify that that is indeed a solution that works. So what I mean is, for example, we could take a very simple number like I'm guessing that maybe x is equal to 0, right? So what would that mean? That would mean that 5x plus 1 would be 5 times 0 plus 1, which is equal to 1. It would mean that 2x plus 6 would be 2 times 0 plus 6. It would be 6. And 4x minus 3. Oh, I hope you can't hear the hammering going on in the background because I will lose my mind. Right, so the sequence would then be the numbers 1, 6, and minus 3. So how I would then verify whether my guess is indeed correct is, well, okay, does the sequence satisfy the conditions it's supposed to satisfy? This question tells us that these terms are meant to make up the first three terms of a converging geometric sequence. So there's two things going on here. First of all, it needs to be a geometric sequence. And then second of all, not just any geometric sequence, it needs to converge. And by converge, we know that that means the common ratio needs to be between -1 and 1, and it can't be 0. So I would then check whether this sequence does satisfy these two conditions. So I'm just going to label the conditions here, condition number 1 and then condition number 2. Okay, so let's test condition number 1. Okay, condition number 1 would be to check if it's geometric. So then how do I check if a sequence is geometric? Well, I check if 6 over 1 is equal to -3/6. Is the ratio between this term and this term the same as the ratio between this term and this term? And we can already see that, it is not. 6 and -1/2 are not equal. So already, like, this thing has failed. Okay. So let me try and now think of another number that might work. Just give me a moment. I don't know if I'm gonna win here. Okay, let me just keep trying some numbers. Okay, that looks promising. So I'm gonna try the number, let's say maybe x equal to 3. Okay, so now I'll replace my zeros with 3s. Oops, some enthusiastic erasing happening there. Okay, so now my first term will be 16. My second term will be 2 times 3 is 6 plus 6 is 12. And then my third term will be 4 times 3 minus 3, so 12 minus 3, which is 9. So then now with x is equal to 3, my sequence changes to 16, 12, 9. Okay, so now I test my first condition. I check if the ratio between term 2 and term 1, so 12 over 16, is it the same as the ratio between term 3 and term 2? Okay, and if we simplify those fractions, we end up with 3/4 on the left and 3/4 on the right. So this means that my sequence is indeed geometric, so it's looking promising. Now the question is, condition number 2, is that satisfied? So is this sequence converging? And if we look at our ratio, our common ratio, it is between -1 and 1. So that means that condition number 2 is also satisfied. So I have now found an x that works. I'm not sure if it's the only x that works, but more importantly, I have also managed to tease out what I'm trying to solve, right? So firstly, I am trying to find an x such that the ratio between term 2 and term 1 is going to be equal to the ratio between this guy and this guy. And then secondly, the only solutions for x that will be valid are ones where it is between -1 and 1. So if, for example, I solve my beautiful equation and I find that one of the x's is 10, then I know that that solution is not valid because it won't satisfy condition number 2. It won't be between -1 and 1. So this might have been a trivial example of the principle I'm trying to demonstrate, but the larger idea I'm trying to convey is, in a situation where you are given a word problem and you need to translate it into some equation to solve, and you're not entirely sure how to construct that equation, sometimes it can be useful to guess and then analyze how you verify that that guess is correct, because that will often tell you which equations you're trying to solve. Okay, so let's go ahead now and set up our equations and solve. So we want to solve 2x plus 6 over 5x plus 1 must be equal to 4x minus 3 over 2x plus 6. And we have the restriction that both of these, 2x plus 1, we can just 2x plus 6. You know what? I am just going to say, okay, well, I'm going to say r is equal to that. It's the common ratio. And the restriction is that r must be between -1 and 1, and r can't be equal to 0 in order for condition number 2 to be satisfied. Okay, so now let's go ahead and solve this equation. So we can do that by, I guess another restriction would be that 5x plus 1 can't be equal to 0, which means that x can't be equal to -1 over 5. And another restriction will be that 2x plus 6 also can't be equal to 0. And this is because both of these expressions appear in the denominator of a fraction. So we've got 5x plus 1 over here and 2x plus 6 over here. So those are just some more restrictions to bear in mind. Okay, so let's go ahead and solve this. Assuming that neither of these is equal to 0, we can just go ahead and cross multiply. I know some people don't like using cross multiplying, but okay, I'm out of the system now. I can do what I want. Okay, 2x plus 6 times 2x plus 6 is equal to 4x minus 3 times 5x plus 1. Okay, so now we're going to just multiply all of these out. So we've got 4x squared plus 12x plus 12x, so that's 24x plus 36. And on this side, we've got 20x squared plus 4x minus 15x minus 3. So 4x squared plus 24x plus 36 is equal to 20x squared minus 11x minus 3. Okay, so now we get everything onto one side. So we've got 4x squared minus 20x squared, 24x plus 11x, 36 plus 3, right? Have I got that right? C minus 20x squared minus 20x squared, and then plus 11x plus 11x, and then lastly plus 3 plus 3. Okay, righty doos. So I'm just going to go ahead and put that into the quadratic formula, because why would I even try to factorize that manually? I mean, I won't lie, there's definitely a part of me that wants to try and factorize this manually. I'm going to factorize it manually. Okay, so we have 39 times negative 16. We're looking for factors of this product that will add up to 35. Okay. And okay, so 39 and 16 doesn't work because the difference between them is 23. So that's not quite it. So 39 is the same as 3 and 13. 16 is the same as 2 and 8, or 4 and 4. So let's see if we can combine these factors in interesting ways. So that means that if I look at 13 and 2, that gives me 26 as one of the factors of this number, and then its partner will be 3 and 8, so 24. Okay, the difference between them is 2, so that definitely doesn't work. What about 13 and 8? Oh, that's too big. 13 times 8 is like, what, 104, and then this is 6. That's not going to work. 8, what about 4 and 13, which is 52, 4 and 3, which is 12, the difference is 40. Hey man, that was close. 4 times 4 times 3, 4 times 4 is 16, times 3 is 48, so this is looking good. And then the other factor will be 13, and the difference between them is 35. Haha, success. So this is going to be minus 16x squared, and we're gonna need this to be plus 48x minus 13x in order to have a plus 35x plus 39. Okay, and now I can factor out a common 16x here, so then I've got x minus 3, and here I can factor out a common minus 13, so then I have x minus 3 again, and so we have x minus 3 times minus 16x minus 13. Oh, that was actually such a yummy one to factorize. Wow. So then we got either x is equal to 3, which is indeed one of the solutions we found, or minus 16x minus 13 is equal to 0, or not or, is equal to 13, and then x is equal to negative 13 over 16. So these are the two possibilities. But now we said that okay, we just need to make sure that none of the restrictions are violated. So we need to make sure that our r is between minus 1 and 1, right? Because none of our x's violate these restrictions, so we're good. Okay, so let's check then. Okay, I'm just going to keep this on the side here. So when x is equal to 3, I mean, we already verified this one when we were doing our guesswork. R is equal to 2 times 3, and obviously we just need to check the one side because, you know, we've shown that for these two values, these two things are the same, so we don't need to check both. Of course, like for your own sanity, you can check both, but in terms of mathematically, you don't need to. So this is 12 over 16, which is 3/4. So this one works because r is between negative 1 and 1. And then let's check the other one. When x is equal to negative 13 over 16, we have r is equal to 2 times negative 13 over 16 plus 6 divided by 5 times negative 13 over 16 plus 1. Okay, that one is definitely for the calculator. That's not pain I'm in the mood for. So we have 2 times negative 13 over 16 plus 6, and then 5 times negative 13 over 16 plus 1, and that gives us negative 10 over 7, which is negative 1 3/7. And that is smaller than minus 1. So this does not satisfy condition number 2. Our sequence is not going to be a converging sequence if we use this ratio. So our only answer is that our only solution is indeed that x can only be equal to 3. Right. Let's see what the memo thinks of our thoughts. So they also, okay, I don't know if they use cross multiplication. Let me not. I think in general cross multiplication is fine. Like, let's just remove the stigma from cross multiplication, if it even exists. This might just be my own thing. Anyway, yep, they agree that x is equal to 3, and they disqualify x equal to minus 13 over 16. So I have spoken sense, guys. I have spoken sense. Thank you for coming around, and yeah, catch you another time for another rainbow.